Welcome to Pindar Poetry. We hope you learned something new.
You need minimal tools and a clear plan. Install Python 3. X and NumPy, then create a virtual environment. Once done, pick a simple feed-forward architecture and define layer sizes so implementation stays focused. Next, load and normalize your dataset, split it into train, validation, and test sets to avoid leakage. Now create basic matrix shapes for inputs, weights, and biases and write functions to initialize them. Start with small dimensions so you can verify shapes and outputs quickly. You will implement the forward pass first. Multiply inputs by weight matrices, add biases, and apply activation functions. Test outputs on known inputs. Once that works, add the loss computation. Use cross-entropy for classification and check that loss decreases on simple examples. Then derive gradients for each parameter and code backpropagation to compute them. Make sure to include a stable implementation of softmax and numerical safe log operations. Finally, update weights with a learning rate eta and optionally momentum. You should now wire training loops. Shuffle data, run minibatches through forward and backprop, update parameters, and log train versus validation loss each epoch. Once training stabilizes, evaluate on the held-out test set and compute the metrics that matter for your task. Save model weights and training metadata. If things go wrong, check one critical troubleshooting item. Verify gradient magnitudes. If they are not n or explode, reduce the learning rate. Use gradient clipping or reinitialize weights with smaller variants. Make sure to rerun small experiments.
Thanks for watching. Consider subscribing if we helped you.